All right, so this is AP Calculus. This is the solutions to worksheet 5-6. This is the key. So I'm taking the antiderivative of the derivative. So this is kind of using the fundamental theorem of calculus, where I say if I go forwards and backwards, I'm left with just f of x. And I can make this slightly wider. F of x, evaluation bar between 0 and c. When I do that evaluation bar and I'm plugging these things in, I get f of c minus f of 0, and that's my final answer. Box it. Yeah, James.
Wouldn't that be a capital F?
It's not going to be a capital F. If I didn't have this prime here, then yes, it would be a capital F. In this case, I'm going to have a capital F down here with a taxman involved. Yeah, good question. All right, let's move down here to number 2. I can zoom in to make this a little bit easier. All right, so this is a case where I need to use taxman because the derivative of the inner is 2, which is not 1. So taxman, I need a u, which is 2x. I need a taxman, which I don't have one, so I'm just going to say my taxman is 1. Gio?
Can you, okay, so I don't get number 3.
I will get to number 3 in just a second.
But like,
I will get there in just a second. All right, so, and then my u prime is equal to 2, and I'm going to divide those to get my paid taxman is 1/2. So I'm rewriting this integral. This integral is now the definite integral between 1 and 3 of 1/2 of general house f of 2x dx. Okay, now that I've paid the taxman, I can go ahead and have permission to take the antiderivative, which is 1/2, and then lowercase f turns into capital F. 1/2 capital F of 2x. No cake this time, evaluation bar between 1 and 3. So once I actually evaluate this thing, I have 1/2 capital F of 2 times 3. I'm plugging in 3 into this x here, and that's going to be 6. So f of 6 minus 1/2 capital F of 2. That is my final answer. I could have factored out this 1/2. I could have rewritten it a slightly different way. I could have said that's the same thing as 1/2 in parentheses, or I guess square brackets because I need parentheses later, capital F of 6 minus capital F of 2.
wait, I need to take a break though.
You went to the bathroom. All right, so for number 3, I need to figure out if I need to use taxman. I don't need to use taxman because this is just powerhouse. The inside of powerhouse is x and the derivative of x is 1, so no taxman needed. The antiderivative, this is going to go x to the power of, it goes up a power to -2, and then divide down by -2, evaluation bar between 1 and 2. So when I actually when I do the evaluation, I'm going to plug in 2. Actually, let me rewrite this. I don't like negative powers. It's kind of confusing. So this is really 1 over -2 x to the power of 2, evaluation bar between 1 and 2. So now I can do the evaluation because I don't have any negative powers. It's much easier to see, oh, this is just going to be 1 over -2 times, I'm plugging in 2 first, so 2 squared is times 4. Or I can leave this as 2 to the power of 2 if you want to just not do too much math. And then I need to subtract 1 over -2. This is going to be 1 to the power of 2. Notice that I have a double negative here, negative and a negative, so I'm going to make those both positives. And when I add these things, I'm left with a negative 2 to the power of 2 is 4 times 2 is 8, so negative 1/8 plus, and then this is going to be 1/2. I have to do a little bit of math here to manipulate this thing. I have to multiply this by 4 over 4 in order to add fractions to have like denominators, and then there's going to be 4 on the top. 4 minus 1 is 3, so my final answer over here is going to be 3/8. Final answer, and box it. Did I box my last answer? Not really. I should box this last answer. All right, on to number 4. Number 4, it's in a fraction, and I say, ugh, gross fraction. I need to convert that into a non-fraction first. So my new integral, my definite integral between 1 and 2 is x to the negative 2 power dx. I asked myself, do I need to use TaxBan? And if you use TaxBan, you are wasting your time because you don't actually need to. You'll still get the right answer. Let's go ahead and take the antiderivative. Antiderivative, this is x to the power of, it goes up a power to the negative first power, and then divide down by negative 1, which is the same thing as multiplying by negative 1, so I'm just going to put a negative out front. Then I need to do an evaluation bar between 1 and 2. So let's go ahead and rewrite this thing. Switching back to a fraction, this is really negative 1 over x, evaluation bar between 1 and 2. And now I will do the evaluation. So now this is going to be equal to negative 1 over 2. I plug in the 2 first. Subtract negative 1 over 1. Again, because I have the double negatives, they're going to turn into a plus. What is 1 minus a half? And the answer is a half. So the final answer is a half. I should do that in red. Is equal to 1/2 and box it. All right, that was number 4. We're on to number 5. Ooh, it actually told us the answer. The answer is 0, but we need to figure out what k is in this case. So let's go ahead and compute what this left-hand side is going to turn into. So this left-hand side, I don't need to use TaxBan. I'm just going to take the antiderivative. This is going to be x. It goes up a power to the power of 3. Don't forget to divide down by 3. Evaluation bar between negative 3 and k. So between negative 3 and k. So I'm only working on the left-hand side here, so this is still equal to 0. The left-hand side, I'm going to plug in these values. So this is now going to be k to the power of 3 divided by 3 minus, I'm going to plug in this negative 3 in parentheses because I'm doing substitution. Always put parentheses whenever you're substituting. I should have put parentheses here. I just dropped them because I knew it was a positive. Negatives are the things that might trip you up. Still to the power of 3 divided by 3. And that's still being set equal to 0. The right-hand side is still 0. Am I going to run out of room? Oh, I have plenty of room. I can always move up to the top right. So simplifying this a little bit, I have k to the power of 3, and then negative 3 to the power of 3 is negative 27. So this right here is negative 27. And notice I have a negative 27. This is really plus 27. So I come back and I say this is really plus 27. I feel a sneeze coming on. All over 3. That's still being set equal to 0. Yes? I did that a slightly different way on the answer key. I'll still get the same answer. I could have just treated this as a 9 and then moved it to the other side. In fact, that's might be easier. Well, let's see what happens. So I'm running out of room. What I'm going to do to get from this step to this step is I'm going to multiply both sides by 3. If I multiply both sides by 3, I'm left with, 0 times 3 is still 0. So on the left-hand side, I'm basically getting rid of the 3. K to the power of 3 plus 27 is now equal to 0. I multiply both sides by 3. I'll maybe show my work. Times 3 times 3. My next step is to subtract 27, so I get k to the power of 3 is equal to negative 27. And then I take the cube root of both sides, so the cube root of k to the power of 3, the cube root of negative 27, and I get my final answer in red here, which is that k is equal to the cube root of, well, actually, I can simplify that. The cube root of 27 is 3, so k is equal to negative 3. Final answer, and box it. Whenever you have an odd index or an odd power, the negatives don't really go away. They stay there. So you're allowed to take the cube root of a negative. You don't have to go into complex numbers. You don't have to do imaginary numbers or anything like that. So I think I left it as the cube root of negative 27 in my answer key. I only know that because I'm taking a quick peek at Stego's computer screen. The correct answer should be negative 3. That was number 5. Let's move on to number 6. So number 6, do I need to use TaxBan? Not really. I'm really distributing this definite integral into both of these two terms. You're allowed to distribute whenever you have no power right here. This is really the power of 1. Whenever that happens, just distribute it. So I'm really saying this is the definite integral between, that was a horrible integral symbol, the definite integral symbol, integral of between 1 and 3 of 2x dx plus the definite integral between 1 and 3 of negative 4. Or I can think of this maybe as minus the definite integral between 1 and 3 of 4 dx. So that's kind of what I'm thinking of in my head. When I actually do the math, this is what happens. The antiderivative of 2x is 2x goes up a power to 2, divide down by 2. The antiderivative of 4 is 4x, so I'm going to be subtracting 4x. And now I'm going to take the evaluation bar of this entire quantity, so maybe I should put parentheses around here to let you know that this entire quantity is being evaluated between 1 and 3. So when I do that, I get, let's plug in 3 first, because I always do the end value first. This is going to be 2 times 3 squared all over, well, I guess I don't need that 2 up front, do I? These 2's really cancel out, so let me leave a bar right there to let me know. It's really just 3 squared minus 4 times 3. That's what happens when we plugged in the 3. So I'll put square brackets to let you know that's when we were plugging in 3. Then we subtract whatever happens when we plug in 1. When we plug in 1, I get 1 squared. 1 squared minus 4 in parentheses 1. And then I can simplify that. 3 squared is 9 minus 12. All of that minus, and then 1 minus 4 is negative 3. 1 minus negative 3. 9 minus 12 is negative 3, so I get negative 3 plus 3, and my answer is 0. I kind of want to make that red to make it stand out as my final answer. All right. Are there questions up to this point? Everyone's just kind of doing their own thing. That's cool. Okay, let's do number 7. Wow, there are a lot of pages on this one, aren't there? For number 7, we are taking the antiderivative. No taxman needed. Kind of the same thing where I'm distributing this integral. So I'm going to take the antiderivative. It goes 4x to the power up. So 4 to the power 4, divide down by that 4, minus 6x squared, divide down by that 2. Evaluation bar between 1 and 2. Notice that these 4's are going to cancel out. This cross cancels into a 3 right here. So I'm really plugging in 2 into that x. So I'm equal to 2 to the power 4 minus 3 times 2 squared. That was the first time that I evaluated. And then I subtract, plug in 1. So 1 to the power 4 minus 3 times 1 squared. Okay, I'm not going to show as much work in this case. 2 to the power 4 is 16. So I can write a 16 up here to show my work. 2 times 2 is 4, so this is going to be minus 12. And this is going to be 1. I'm really just showing all my work anyway, aren't I? 1 minus 3. So my final answer, well, at least a step before my answer, is 4 minus negative 2, which is 4 plus 2. The answer is 6. All right, I'm on to number 8. Ooh, another problem where I work on the left and the right side. So, working on the left-hand side, taking the antiderivative, this is x to the power of 8 divided by 8 plus kx. Evaluation bar between negative 2 and 2. That's still equal to 16. 16 is going to be on the right-hand side the whole way down. All right, so plugging these in, I get 2 to the power of 8 all over 8 plus 2k. That's what happens when I plug in positive 2. And I'm going to subtract what happens when I plug in negative 2. Negative 2 is going to be negative 2 in parentheses to the power of 8. I had parentheses because I have a negative value. All divided by 8 plus, actually this is going to be minus now since the negative 2, minus 2k. So that's the left-hand side. The right-hand side is still 16. All right, so simplifying a little bit, 2 to the power of 8. Ooh, I'm going to have to do some scratch work off to the side. So 2, 2, 2, 2, and then I'm going to do that again, I guess. So I'm going to multiply this. I'm going to square this. It's really this squared is what I'm looking for. So 2 to the power of 4 is 16, and then 16 squared is really the same thing. Is there any quick shortcut? That's really 8 squared times 2 squared. So 64 times 2 times 2. I'm basically just doing this the long way, aren't I? 256. Whew. And I can check on my calculator as well. 2 to the power of 8 is 256. So this is really another way to think about this. I'm realizing now I should have done this earlier. 8 is really 2 to the power of 3. So I'll say that this is 2 to the power of 3 right here. And when I do rules of exponents, 8 minus 3 is 2 to the power of 5, and 2 to the power of 5 is 32. And I can check that as well. 2 to the power of 5 is 32. So I'll write down here 32 plus 2k. Lots of work to solve that, I know. And then this is going to be the same thing, because whenever I have an even power, it's going to become a positive value. So I still have a 32 there. 32, and I'm going to distribute this negative, so it's a negative 32, distribute the negative here and here, I get a positive 2k. So positive 2k, and that's equal to 16. Running out of room, let me come back up here to the top right-ish area. I now have 4k, because the negative 32 and 32 cancel each other out, is equal to 16. Dividing both sides by 4 gives me my final answer of k is equal to 4. Final answer box it. Number 9. This one I'm going to have to, you can either use Taxman or you can square. There's 2 methods of doing this. I like using Taxman, so I'm going to do that. So this is my power house. What's inside my house? The inner is 3x minus 2. That means the derivative of this 3x minus 2 is 3. Therefore, I need to use Taxman. It's not 1. The other way I could have done this is going square the first, 9x squared, double the product, negative 12x, and square the last, plus 4, and then taking the antiderivative of each of these 3 terms individually, which does not require Taxman, but I'm doing it with Taxman. So now I've shown you both methods, I suppose. U is 3x minus 2. Taxman. There's no Taxman. And then u prime, the derivative of 3x minus 2 is 3, which means I'm going to pay Taxman 1/3. Let's go ahead and pay Taxman. So it's still the integral between 0 and 1. And I'm paying Taxman 1/3 and rewriting the rest of this stuff. 3x minus 2 all to the power of 2 dx. All right, so I paid Taxman. I now have permission to take the antiderivative. This is going to go 1/3 in parentheses. I might want to move these over a little bit. 3x minus 2 all to the power of now 3, and then divide down by that 3. Dividing by 3 right here is the same thing as multiplying by 1/3 out front. And then that's going to be evaluation bar between 0 and 1. Do I have any room on the right? Oh, I have plenty of room. So this is now equal to, I really want to think about this thing as 1/9. So it's going to be 1/9. And here's a cool trick. If I have some number out here, I can leave that number factored out, which means when I factor this thing out, now I'm going to only worry about plugging this 1 into only this stuff right here. Don't worry about this. So when I plug in that 1, it's 3 times 1 minus 2, which is 1. So 1 to the power of 3 is 1. 1 to the power of 3. And then minus, what happens when I plug in 0? 0 times 3 is 0, minus 2 is negative 2, negative 2 to the power of 3, minus negative 2 to the power of 3. All right, so simplifying this a little bit. So 1 minus, and then negative 2 to the power of 3 is negative 8. Negative 8 is positive 8. So that's going to be a positive 9. That's going to be 9/9, which is just 1. And there's our final answer. I guess I can write that in, I'll go like this. I'll say this is equal to 1/9 times 9, which is equal to 1. All right, moving on to number 10. Number 10, I don't like fractions. Get rid of it. So this is now the definite integral between 1 and e of x squared plus 1, that quantity, times x to the negative 1 dx. All right, so I think we're going to have to use Taxman, yeah, because which house are we in? Which is the house that I should really be looking at? I think this is going to be my most inner of the houses. So if that is my house, then my inner of my house is x squared plus 1. My taxman is x to the negative 1, and my u prime is equal to, oh, that's not good. So this is a case where we're paying taxman a variable rate, and we can't do that. So how do we take the antiderivative of this function? So I'm going to show my work and say that this doesn't work.
Trash.
I think in the old answer key, it wasn't fully explained. Why are you doing this other method? Taxman doesn't work, so we have to have some other method of doing this. So I'm going to kind of cross out all of this stuff, cross off all of this stuff. I'll leave it there, of course, and begin the problem again. So my new process of setting this up is to separate these fractions. So this new integral, I'll say, is equal to the integral from 1 to e, and I'm going to separate the fraction, so it's really x squared over x plus 1 over x, and then all of that stuff times dx. I'm allowed to split up the fractions like that, which means I can now kind of distribute this integral into both of these two terms. And notice that the x squared and x are going to cancel each other out. So when I take the antiderivative, do I have enough room on the right? Oh, I have plenty of room. So this is going to be equal to, the antiderivative of x is x squared, then divide down, so over 2. And I don't like fractions. This is really, this guy right here is really x to the negative 1. So x to the negative 1, that's log house, because I can't divide down by 0. So this is going to be plus the natural log of absolute value of x. Okay, and that is going to be evaluation bar between 1 and e. All right, so I'm going to come down here now. When I evaluate this thing, I'm going to plug in e first, so I get e squared over 2 plus natural log. I could say absolute value of e, but I know e is positive, so I'm just going to drop it right now. Natural log of e. So that's what happens when we plug in e. Let's subtract what happens when we plug in 1. So if I plug in 1 to this equation, I have 1 squared over 2, which is just 1/2, plus the natural log of 1. Again, I'm dropping the absolute value because the absolute value of 1 is just 1. So kind of important thing to know, the natural log of 1, that's just 0. It's one of those definitions that you need to know. And the natural log of e, that is equal to 1. So when I simplify this thing, that is now going to be equal to e squared over 2 plus 1 minus 1/2. And that simplifies nice and simply because that all is very nice. It's 1/2. So it's really e squared over 2 plus 1/2. And I guess another way of saying that is it's e squared plus 1 all over 2. Either of those two answers are the same, so I'm going to box both of them. Two different forms of an answer. All right, on to number 11. And number 11, 2x plus 2. All right, so this one is, I think taxman might actually work. Let's always try to do taxman. All right, so number 11. We have to rewrite it without a fraction. This is now going to be the integral between 1 and 2. I guess I can put these on the top and bottom. 1 and 2 of x plus 1 times the quantity of x squared plus 2x, all of that to the power of negative 1 dx. All right, so the house that I'm seeing is this thing. It's a power house. I know there's going to be eventually a natural log house, but for now the inner of this is x squared plus 2x, and clearly dinner is not 1, so I'm using taxman. So u is x squared plus 2x. Taxman is x plus 1. And the derivative of u prime, is 2x plus 2. And notice that these seem to not cancel anything out, so I'm going to rewrite this as x plus 1 for the numerator, and the denominator I'm going to factor out of 2. So I'm left with x plus 1 after I factor that out. And finally, those will cancel out, and I'm paying taxman 1/2. So our new rate, I'll do this over here, is the integral between 1 and 2. We're paying taxman the rate of 1/2. and I copy down everything else that I had before, which is x squared plus 2x, all this to the power of -1 dx, and I'll do a line here. This 1/2 went right there, and then I can take the antiderivative. I've paid taxman, so I have permission to do that now. When I take the antiderivative, this is going to be 1/2, and then the antiderivative of anything that has a -1 is the natural log of whatever that inside was. So it's going to be natural log, technically, of the absolute value of x squared plus 2x, and absolute value. And don't forget your cake. No, not cake. It's the absolute value bar. It's the evaluation bar, rather. 1 and 2. And when I do that evaluation, let's plug that in. I think I have enough room. I don't know why I did it on the next line. Let me move this around. I thought I was running out of room, so let's go ahead and move this back down. I'll get rid of this black line. And after some technical difficulties, now I can take the evaluation bar, I can actually plug in these numbers. So I'm going to have 1/2 natural log of, when I plug in 2, this is going to be natural log of 4 plus 4. And then I'm going to subtract 1/2 natural log of, when I plug in 1 plus 2. 1 plus 2. And again, I'm dropping the absolute value bar because the absolute value of 4 plus 4 is 8. Like, it's already positive. If it was negative, then I would have to worry about that. Making the next jump, the next step here. So 4 plus 4 is 8. So it's 1/2. I'm factoring on the 1/2. And it's going to be natural log of 8 minus natural log of 3. Natural log of 3. And again, this actually is a good final answer, but there's another way of writing this. And there's actually a few different ways of writing this, but I'm going to show you at least the other one that I'm thinking of. If you ever have natural logs that are being subtracted, you're really dividing on the inside. So this is equal to 1/2 natural log of 8 divided by 3. And that is, again, the same thing. There's a bunch of forms. That's also the same thing as natural log of the square root of 8 divided by the square root of 3. And I'm kind of skipping a step there. It's really 8 to the 1/2 power, or you can think of this as 8/3 to the 1/2 power, all that to the, it's really the 1/2 power is on the inside. Maybe I have like a double set of parentheses there. That would make sense. So just be comfortable with all 3 of these different forms. Let me just box all of those, I suppose. Yeah, using rules of logarithms, because again, there's going to be multiple choice. Maybe they'll give you something like natural log of square root of 8 over square root of 3. And you're like, what? How did you get from here to there? And yeah, there are a lot of steps that you might need to have to review. Number 12. It looks like weird product rule, anti-product rule. How are we going to do this one? I think we're going to have to distribute this x into both of these 2 terms and then take the antiderivative, because there's no way of undoing multiplication. So yeah, let's go ahead and rewrite this now as the integral from 0 to 1 of, so this is really, I'll make a note up here, this is really x to the 1/2 power. So when I distribute that into x to the 1 power and distribute that into x to the, or just 1, it's going to be easy, but I'm going to add 1 and 1/2 for that first term. So I'm really going to have x to the power of 1.5, or 3. That's not a good 3 halves. And then this is going to be plus x to the 1/2, because that's a nice easy distribution. That's all multiplied by dx. Do I have enough room over here? I think so. So from here, now I can actually take the antiderivative. When I take the antiderivative, I don't have to worry about taxman because the inner is x, the inner is x, both of them are okay. Taking the antiderivative, I'm going to move down here a little bit, is equal to x to the power of, I'll move over a little bit actually, x to the power of 5 halves. I go up a power and then divide down by 5 halves, which is the same thing as multiplying by 2/5. And then I'm going to add, this is now x to the power of 3 halves, divide by 3 halves, that's the same thing as multiplying by 2/3. And don't forget our cake, plus c. And then I can rewrite this again in another form. You should be comfortable with all of your different forms. This can be the same thing as 2/5 the square root of x to the power of 5 plus 2/3 the square root of x to the power of 3 plus c. So both of those forms you should be comfortable with. I'll go ahead and box both of them. Come up here a little bit, not to run into the other box answer. All right, and number 13. What am I doing? I took the antiderivative, but I didn't do an evaluation bar, Mr. Sindel. Maybe I should probably use this form when I do my evaluation bar. So let me leave the evaluation bar there, because it's not plus C. Yeah, this is embarrassing. Don't know what I'm thinking today. Get rid of the plus C, Mr. Sindel. Come on, grab. No, not the whole thing. There we go. Computer is just lagging behind. Evaluation bar between 0 and 1. Now I'm realizing that all of this was a waste of time. Let me go like this. All right, this is not plus C. Let's get rid of that. It's evaluation bar. I've made the mistake again. Hi-ya. All right, so evaluation bar between 0 and 1. Again, those are the bounds of this integral. When I plug in 1, what's going to happen here? 1 to the power of 5 halves. Well, 1 to any power is always going to be 1. So this is really just 2/5 here. And then 1 to any power again is 1, so plus 2/3. So this is what happens when we plug in 1. Then I'm going to subtract what happens when we plug in 0. 0 to the power of anything is 0, and 0 times anything is 0. So I'm really just subtracting, I guess I can say 0 plus 0. You're really just subtracting 0. I'm going to make this minus 0. And then from here, it's pretty straightforward. I just have to add I have to have like denominators in order to add my fractions. Doing the math really quick, I'm going to have, let's use black here. So I'm going to multiply this by 5 over 5, this one by 3 over 3. So that's going to be 6 plus 10 is 16, and 3 times 5 is 15. The answer is 16/15. All right, moving on to number 13. Let's try to get less errors if possible. This one, I'm going to get rid of the radical symbol and turn it into a non-fraction at the same time. So this is going to be an integral from 0 to 8 of 1 plus x, that's going to be on the inside, to the power of negative, because it was a fraction, and then 1/2, because it was a radical, dx. All right, let's go ahead and take the antiderivative. Antiderivative of this guy is going to be 1 plus x, now to the power of, I'm going to go up a power to 1/2, and then divide by 1/2. That's the same thing as multiplying by 2. And you might be asking, wait, what happened about Taxman? I don't need to use Taxman in this case, because here's your inner, right? The derivative of 1 is 0. The derivative of x is 1. This is a case where dinner is equal to 1. So I'll make a note here that right here, the inner is equal to 1, no Taxman. Maybe with a little smiley face, because that's less work for us, right? And then, so I divided down, good. Okay, evaluation bar. Oops, let's keep it with yellow. Evaluation bar from 0 to 8. 0 to 8. All right, so now I'm going to plug in 8. What happens when I plug in 8? This is going to be 2 times the quantity of 1 plus 8, so that's actually 9. So I'm going to say 2 times 9 to the 1/2, and then I'm going to subtract, I'm going to factor out this 2 too. I'm doing a lot of things, so I'm factoring out the 2, so I don't have to worry about the 2 until the very end. And then what happens when I plug in 0? I'm going to get 1. 1 plus 0 is 1, so 1 to the 1/2 power. And let me see if I can get rid of that little dot to make it look a little bit cleaner. Finally, what is 9 to the power of 1/2? That's a square root of 9, so I'll rewrite that. That's a square root of 9 and the square root of 1. So the square root of 9 is 3. 3 minus 1 is 2. So I'm really doing 2 times 2, which is 4. Final answer, box it. All right, number 14. All right, kind of same thing where I'm going to get rid of the rational function, get rid of the fraction, right, and then get rid of the radical, the square root. So this is now equal to the integral between 0 and 1 of, I still have this 2x, and that's going to be multiplied by 1 minus x squared, all to the power of negative 1/2. Okay, this is a case where dinner is negative 2x, so I definitely have to use Taxman. So, Taxman, I need a u. That is 1 minus x squared. That's not a very good x squared. Let me try rewriting that x squared. That looks a little bit better. Taxman at the front door, he is 2x. And then u prime, the derivative is negative 2x, which means I'm going to pay Taxman negative 1. So this 2x got turned into a negative 1. That is going to equal the integral between 0 and 1 of negative, in parentheses here, and I guess it's all the same stuff, so I'm going to leave it as blue, 1 minus x squared to the power of negative 1/2. Again, I should probably draw arrows that this negative 1 went right there. I don't know why it's so squiggly right there. Interesting. And don't forget our dx. dx. Just to be formal. And then I can take the antiderivative. I'm taking the antiderivative now. Let's switch back to yellow. Antiderivative, this is going to be a negative, in parentheses, 1 minus x squared, all to the power of, it's going to go up a power, up to the power of positive 1/2, and then divide by 1/2. That's the same thing as multiplying by 2. So let's move all this stuff over to the right a little bit and multiply by 2. Multiply by 2. What's going on here? Multiply by 2. And then evaluation bar between 0 and 1. So come over here, evaluation bar between 0 and 1. What happens when we actually do the evaluation? When I plug in 1, I'm going to get 1 minus 1, which is 0. 0 to the power of 1/2 is 0. 0 times negative 2 is 0, so 0. Nice. Okay, and then I'm going to subtract. What happens when I plug in 0? 1 minus 0 is now 1. 1 to the 1/2 power is 1. 1 times negative 2 is negative 2. So negative 2. I have a double negative, so my final answer here is going to be 2. Final answer, and box it. And number 15, we go all the way to problem 17, so I'm almost there. All right, so E-house. I love E-house. Okay, so I need to use Taxman because here's the inner, so, and then the dinner is going to be negative 4. So U is equal to negative 4x, the inner, and then I don't know why I'm using yellow. I should use blue first. I want to be consistent. And then my taxman, there is no taxman, so 1. And then the derivative of 4x is 4, so I'm going to pay taxman 1/4. So rewriting this with taxman being paid, this is now the integral from 0 to 1 of 1/4 of e to the power of negative 4x dx. All right, let's go ahead and take the antiderivative of e-house, which is so fun to do. You just rewrite it, 1/4 e to the negative 4x. And not cake, it's evaluation bar from 0 to 1. What happens when we plug those things in? So when I plug in 1, this is going to be e to the power of negative 4. So I'm going to leave this 1/4 out front. I'm going to always, whenever I have a number out front, I should always leave it factored out. It's less work for me to do. And only worry about, I don't know what happened there, only worry about this stuff when I'm plugging in. Don't worry about the 1/4. So when I plug in 1, I get e to the negative 4. Okay, I'm going to subtract. What happens when I plug in 0? This is going to be e to the power of 0. So e to the power of 0. All right, so when I simplify this, e to the power of 0, we know that turns into 1. Anything to the power of 0 is 1. And e to the negative 4, I'm just going to flip that around so it's 1 over e to the positive 4. And my answer is, I have nothing on the top, right? No, wait, I have to be careful. So I have 1 over e to the positive 4, and that's minus 1, and that's all divided by 4. Another way of writing that is distributing the 4 onto the bottom. And if I distribute the 4, it's 4 on the bottom, 4 on the bottom, and that still doesn't look very clean. So you can leave it as either way. So I'll leave it like minus 1 all over 4, which is the same thing as 1 over 4e to the 4 minus 1/4. Both of these are the same answer, so I'm going to box both of them. Just trying to show you all the different equivalent forms that you might see. All right, second last question. Yes, trig house. So antiderivative and with x, interesting. So this is kind of a prelude of what's going to happen in the next, not next unit, but like in next year, I suppose. Antiderivative of sine is cosine, and is it positive or negative? Same, S for same, is change. So I'm going to change the sign to a negative. So negative cosine of t. Evaluation bar between 0 and x. All right, so let's go ahead and plug these in. When I plug in x, I leave it as negative cosine of x. And then I'm going to subtract. Again, I'm going to plug in 0. Cosine of 0 is 1, but I'll write it out here. It's going to be negative, so double negative here, negative cosine of 0. Again, where did this double negative come from? You always subtract the right bound from the left bound, so that's where this subtract came from, and then this minus sign came from that one. And then simplifying this a little bit, yeah, cosine of 0, we all know that's 1. hopefully. If you don't know why it's 1, a quick explanation is, what is this angle? Angle is 0. That means I come out here. If this is on the unit circle, what is the x-coordinate? Because cosine means x-coordinate, and that x-coordinate is 1. So this simplifies as negative cosine of x plus 1. Final answer, and box it. And finally, number 17. All right, so antiderivative of sine is anti-same. Anti-same is change, so it's going to change to a negative, and then cosine of x. Again, don't worry about dinner, or don't worry about taxman, because dinner is 1. Absolute or evaluation bar between 0 and pi over 4. And what is that going to equal? So when I plug these in, I'm going to have a negative. I'll leave that out front. Don't worry about the negative for now. So I'm going to have cosine of pi over 4, and then I need to subtract whatever I get with cosine of 0. And this is a time where we really want to pay attention to our unit circle. Oops, our unit circle. And our unit circle, pi over 4 is right there. And so if I'm looking at cosine, the x-coordinate of pi over 4, whenever I have a 45, 90, both of these lengths are square root of 2 over 2, square root of 2 over 2. It's in the first quadrant, so both of these are going to be positive. So that means that this is going to turn into, I guess I don't need to cross it out, but it's going to equal, so negative out front, square root of 2 over 2. And then cosine of 0 is going to be right here, and cosine is the x-coordinate, so 1, so minus 1. And then distributing that negative gets us our final answer of negative square root of 2 plus 1. Or you can flip it around and say 1 minus square root of 2 over 2. The final answer, box it.